Hello, everyone. Happy Friday. All right, so again, I'm thinking they already said this, but just in case, if you're here for 2412, you want to click the link that they're going to post in the chat. All right, so today for our Happy Math Hour, we're supposed to review for exam 1, and last week we didn't quite finish the Venn diagram section, so that'll be part of the review for the exam. So we're going to start with that, and let me just log in to Friday Happy Hour with my other device because I'm going to use that here in a second. Let me just call myself Ivetruka 2. And then if you can make me a presenter for that account as well, that would be great. Okay, let me just mute my mic. All right, so let's get started here. So for a Venn diagram, Venn diagrams are usually, they look something like this, where you have a rectangle, and inside of the rectangle, you're going to have circles. And so the circles represent the sets. So on the left side, we have two sets. We call them A and B. And so set A is represented with the left-hand circle, and set B is represented with the right-hand circle. The entire box represents your universal set. In the right side picture, we have three sets. We have set A, set B, and set C. And so as you notice, the circles, they overlap with each other. And so we're going to be talking about what that means as well. So last time we also talked about the complement of a set. And we said that the complement of a set, which the symbol for complement is this apostrophe here. And we said that it's all the sets that are in the universal set that are not in the set A. So for example, here, our set A is the circle. And so if we want to find the complement of A, it's going to be everything that is not in the circle A. And so that would be represented with the area that is shaded in blue, which is on the outside of the circle. So the complement, that would be your complement. And then also here we can, just to review from last time, set A is considered a subset of set U. Since everything in A is inside of U, then A is a subset of U. Okay, so the next term here that we want to talk about is intersection. And so the intersection of two sets is basically what they have common to both sets. And the symbol that is used is this upside down U. Okay, so this is read as set A is intersected with set B. Now visually in a Venn diagram, the things that are common to both set A and B is highlighted by this blue area, which is in the middle where the circles overlap. So just to kind of review what an intersection is, if we have A is 1, 4, 5, 7, and B is 2, 3, 4, 5, 6, and C is 3, 6, 9, we want to find A intersected with B. So when we're doing the intersection, I normally like to write down what A is. So A is 1, 4, 5, 7, and then I put my symbol intersection. And then B is 2, 3, 4, 5, 6. Since I have the intersection, you want to ask yourself, what are the elements that are common to A and B? Which elements belong to both A and B? So we can see here that 4 and 5 belong to A, but they also belong to B. Therefore, the intersection of A and B is going to be 4, 5. Okay. So for letter C, we have, or for letter B, we have A intersected with C. And so if we were to write down our points, let me go ahead and do that here. So for A, we have 1, 4, 5, and 7. And then for intersected, so I'm going to write my symbol. And then C is 3, 6, and 9. Okay, so this is your C, and this is your A. So you want to ask yourself what elements are common to this set and this set, which belong to both. And so we can see here that there's nothing in common. And so we use our symbol for the empty set. Okay, if you have any questions, feel free to ask your question. And so our next one, we're going to have two sets are disjoint if their intersection is empty. In other words, they don't have anything in common. And we use the empty set as our answer because they have nothing in common. The next term that we're going to look at is the union. So the union of sets A and B, the symbol for union is a U here. And it's the set that contains all the elements that belong to A. They also belong to B or both. So the set of elements that belong to A or to B, or they belong to both. So here, this is our notation, okay? And so let's go ahead and look at to see what it means. And just to kind of refer to this in our everyday usage, union means to put together. So we're going to take everything that is in A and everything that is in B, and we're going to join them together to make one big set. So that is what union means. In the picture for the Venn diagram, it's going to be everything in A and everything in B put together as one set. Okay, so let's look at this example. So we have A is 1, 4, 5, 7, B is 2, 3, 4, 5, 6, and C is 3, 6, 9. So we want to find A union B. And so again, if we list all the elements here for A and all the elements for B, then basically you want to take everything that's in A and we're going to write it down. So we have 1, 4, 5, and 7. Then you want to bring everything from this side here. So you have 2, 3, 4, 5, and 6. And so this is going to create your new set. So A union B is going to be everything in A and B put together in one set. And if something is repeated, you don't have to write it twice. Okay, so same thing for A union C. We have 1, 4, 5, 7 union with 3, 6, 9. So we grab everything in set A and we place it in this new set, everything in set C, and we place it in here. So something that you might find easier to do is to go ahead and do the following. So you have A union C, and then again, if you write everything out, it's usually helpful because we can see it here clearly instead of having to go back to the original problem. And so let me just go ahead and finish writing this. So what you can do to make it easier for you is, since you're looking for the union, that means we're going to put everything together. So I'm going to take my first set, 1, 4, 5, 7. So that's everything in A. And then I'm going to put everything in B. So 3, 6, and 9. The difference between this one here and the one that I wrote is that the one on the left side is written from smallest to greatest, and mine is just all mixed in. And one of the benefits of this is that you won't forget any numbers, right? So either way would be fine. All right, so now let's go on. So again, whenever we're talking about intersection, you want to think of the word and. So for intersection, you're going to think of the word and, or if you see this symbol, then you know that means and. If you see the union, then the word that we use is going to be or. So if you see this symbol, then you want to think about the word or. So it says write a sentence that best describes the set. So we have A union, and then we have B intersected with C. So if you see these symbols, that's the union. So you want to think of the word or. And then here we see this symbol, which is the intersection. You want to think of the word and. Okay, so a possible answer here could be that the set can be described as the set of all elements that are in A, so everything that's in A, or, so that's my symbol for union, so or are in B and C. Okay, so notice we're using the word or and. For letter B, we have the intersection, so we know we're going to have the word and involved. And then we have this symbol here. And so this symbol, remember, is your complement. And so let's see what we can write. So this set can be described as a set of all elements that are in J. So here's my J. And are not in K. So remember, the complement means everything that's not in K. Okay, so that's an example of describing your set in sentences. And so now we're going to work a little bit more with Venn diagrams. So here we have a Venn diagram, and we want to determine each of these sets that are given to us. So the first one, we want to know what is A equal to. So A is going to be everything that you see in the circle A. That is what makes up your set A. So in this case, we have the pound sign, the money sign, and the triangle. They're all inside the circle A. So we would write our answer as pound, money sign, and the triangle. Okay, so then for B, it's going to be everything in the circle B. And so everything in the circle B is 2, 4, 6, and the triangle. So we can write it as 2, 4, 6, and triangle. Okay, so for letter C, we have A union B. So for A union B, we're going to have the union means everything in A and everything in B put together as one big set. And so if we take everything in A and everything in B, then we would write it as pound, money sign, 2, 4, 6, and the triangle. Letter D, we have A intersected with B. So intersection means what they have in common. So you want to look at A and B and ask yourself, what is it that they have in common? And that's going to be where the two circles overlap. So in this case, our answer is going to be just the triangle. Letter E, we have A complement. So A complement means everything that's not in A. Okay, so everything not in A. And so that's going to be 2, 4, 6, and 7. So that's our complement. And then for letter F, we have B complement. So that is everything that is not in B. And so everything that's not in B is going to be your pound sign or number sign, the money sign, and the number 7. Okay. Any questions on this slide? All right, so let's try another one with 3 circles. So here we have 3 subsets, A, B, and C. So we want to find U. So remember that U is the universal set. And if we go back to the previous slide, notice that this picture does not have the U identified. But if you don't see the U, the universal set is just everything that is in this rectangular box. And so we go to the next slide. We want to find the universal set. So that is everything in this box. So we just list it out. And that's going to be everything that you see in the box. So 1, 4, 5, 6, 3, 8, 7, 11, 9, 12, and 2. And then we go to letter B. So we're going to find A. So A is everything in the circle A. So 1, 4, 5, 6, 3, and 8. And we go to B. So the set B is everything in the circle B. So that would be 4, 5, 6, 7, 11, and 9. And then the next one is C. So C is going to be everything in the circle for C. So 8, 6, 9, and 12. And then let's see where we at. So now we want to find A union B. So that's going to be everything in A and everything in B. So I'm going to have 1, 4, 5, 6, 3, and 8. And then everything in B that we haven't used, 7, 11, and 9. Okay. And the last one here is A intersected with B. So that's the things that are common to both A and to B. So if we look at circle A and circle B, the area that's common to both of them is going to be 4, 5, and 6. And so that would be our answer here. And let's try a couple of more. And let's try a couple of more. So we have A union C. So A union C is going to be everything in A and C. So that would be 1, 4, 5, 6, 3, and 8, 12, and 9. I didn't highlight the 9, but thankfully I put it in my answer. So 9 is also part of this solution. Okay, so I'll give you a second to try B intersected with C. See if you can get that answer. Okay, so B intersected with C is going to be everything in B that is common to C. So everything that is common to both B and C. And so that's going to be 6 and 9. Okay, so now we have something with 3 sets. So we have A union B union C. So union means that we're going to take everything in A, everything in B, and everything in C, and we're going to put it all together in one big set. So our answer is going to just be everything in A, everything in B, and everything in C, and that's going to create our set. Okay. And then the last one, letter J, is A intersected with B, intersected with C. And so for that one, it's what do they all have in common? So the thing they have in common is this little part here. So that's going to be 6. Okay. Now, equality of sets. So they tell us here, determine whether A union B complement is equal to A complement intersected with B complement for all sets A and B. So one of the things that is different between this and the previous problem is that in the previous problem, they tell us exactly what A is and exactly what B is and exactly what C is. So for example, A is 1, 4, 5, 6, 3, and 8. But in this problem here, it's saying for all sets A and B. So no matter what A is and no matter what B is, they want to know if we were to take the union complement of that and the complement of A intersected with the complement of B, would it always be true? Okay, or would they always be equal? So there's 2 ways to do it. I'm going to show you one way first. And so, you know, the good thing about this is if you don't like the first way, then maybe the second way would be better for you. Okay. So the first way is to just use Venn diagrams. Okay. So here it says determine whether A union B complement is equal to A complement intersected B complement. So first we'll work with the left-hand side. So here's my left-hand side. And then since I have parentheses here, I want to do what's inside the parentheses first. So I'm going to say we have A union B. And I'm going to highlight my answer for A union B. So A union B means everything in A and everything in B. And so that's our answer just for A union B. However, we still have to worry about the complement. So the complement is everything that is not in A union B. So I'm going to highlight that area in, I guess, what color is this, like turquoise or something? So I'm going to highlight everything that's not in that A union B part. And that's going to be your answer for the left-hand side, okay? So I just broke it down into steps. So first you do inside the parentheses. Then we take the complement, which is everything in this outside of the two circles, A and B, highlighted in turquoise. But now we need to figure out what is the right-hand side. Okay, so that's what we'll do next. So the right-hand side is A complement intersected with B complement. So first, I'm going to figure out what A complement is. So A complement is everything that's not in A. So everything that's not in the circle A, I'm going to shade it in this pink highlighter. So everything in the complement is what's in pink. Then I'm going to need to know what is B complement. So for B complement, we're going to shade it in green. So everything that is not in circle B is your B complement. So that's this area and this area outside of A and B. Okay. Well, when I put pink and the green together, it made this brown looking color. Okay. And so the intersection is, what do they have in common? So what they have in common is going to be that brown looking color, because this brown looking color, in order to get that, I had to have both pink and green there. And so the big question now is, whatever result we got here, which is this area in brown, is it the same as what we got in the first step, which is the area in turquoise? So you can see that our answers are true because the answer is everything that's outside of both circles A and B. And that's what's highlighted in both. So therefore, we can say that the sets are equal. So this is one way to do it, is by highlighting the different sets. Now, the problem with the highlighting is that you have to keep track. You can make a mistake. So another way that I'm going to show you is without using the circles. Well, you kind of will kind of use the circles, but not quite. Okay, so let me see if I can use this mouse. If not, I'll switch to my other device. But let's draw just a Venn diagram here. Let me put it up here. Okay, so we're going to have a Venn diagram. I totally missed the part, but you know that should have been together. Okay, let me just, I think I'm making it worse there. Okay, so then you have A. So this is A. And then we're going to have B. And I know I'm going to have two circles because I'm only working with A and B. Okay. So what you want to do is you start off with just a Venn diagram like this. We just drew it out. And then we're going to label each of those regions. So everything here that just belongs to A only, I'm going to call it 1. And then I'm going to call the intersection 2. And I'm going to call everything that belongs to B just 3. And then there's one more region that we can call 4, and that's everything outside of the two circles. Okay, so now what I can do is I'm going to go ahead and write my set A. So my set A is equal to 1 and 2. Okay, and then my set B is equal to, what numbers are in B? The number 2 and the number 3. And then there's one more set, right? And what set is that? What do we call it? The universal set. So the universal set just has everything. 1, 2, 3, and 4. Okay, so we haven't even started the problem here, right? All we've done is we drew just a Venn diagram, and these numbers represent the areas of each of those regions, okay? So now we're ready to begin our problem here. So we're gonna have A union B, and this is all in parentheses. So again, this is just the second way to do this, okay? And then this is equal to A A complement intersected with B complement. And this is still equal here. So now I want to work with my inside of my parentheses first. So we have A union B. So A union B means that I'm going to put everything in A, which is 1 and 2. 1 and 2. And let me squeeze in my symbol for, let me see, where's the eraser? All right. So let me just squeeze in my, so here's my parentheses. And so my set is everything in A, which is 1 and 2. And then we have union, so that's everything in B, which is 2 and 3. I already have the 2, so I have my 3. And then we have our complement. Okay, so right here, we have our complement. Okay, so now if I have 1, 2, and 3 complement, that's everything that is not in here. Okay, so everything that is not here is going to be your complement. So our complement, what are the numbers that are not in this set here? 1, 2, 3. The only number that's not in here is 4. So that's going to be our complement, our answer for this side, the left side. So now let's go to the right side. So we our complement, our answer for this side, the left side. So now let's go to the right side. So we have A complement. So A complement means what are all the numbers that are not inside of A? So if we look at A is 1 and 2. So the numbers that are not in there are 3 and 4. Then we have our intersection symbol. And then B complement is everything that's not in B, which is the number 1 and the number 4. Okay, so now we're looking at what is the intersection of this set and this set. So what does this left-hand side set have in common with the right-hand side set? And so the number that they have in common is 4. Okay, so if we compare the left-hand side, we got 4 and the right side was 4. And so that means that these sets, or this that we're trying to prove, is going to be true for all sets A and B, okay, because we got the same solution. And if we go back to the previous slide, remember that we had shaded, let me go back, this outside, which represents 4. Okay, so that is the 2 ways that you can figure out how to work out these type of problems. Now the good thing is we have something called De Morgan's Law, and by what we just did over here, what we just proved essentially is that if you have if you have this right here, then this is going to be true. And if we have A intersected B complement, that is also true for A complement union B complement. Okay, so this, if you see this, then you know that's true, and you don't have to do what we just did over here. But sometimes if you forget what De Morgan's Law says, then the good thing is we can work it out. So let's try one that's a little bit longer. We have A union, And then we have A union with the intersection of B and C. And we want to show if it's equal to A union B intersected with C. So I'm going to go ahead and work it out by just putting in the sets here. And if we kind of have a little bit of time, maybe we can draw it out. But again, the idea here is you draw a Venn diagram. And now we're going to have 3 circles. So we have A. I should have made that bigger. I have this whole box and I chose a little piece of it. And then we have B. And we have C. Okay. So what do we want to do next is label the regions. So we're going to have 1, 2, and let me choose a different color. This one's kind of hard to see. Okay, let me just draw the circles bigger since I accidentally erased part of my circle. And it gave me an opportunity just to draw it bigger. All right, so we have A. I guess I didn't do a good job making it bigger. And then B and C. So this is B and C. All right, so now let's label these. Let's use blue. So we have 1, and then this is going to be 2, 3, 4, 5, 6, 7, and 8. So one of the questions that I get asked is, do I have to label this as 1, 2, 3, 4, 5, 6, 7, 8? And the answer is no. In fact, if you look at your ebook, they use Roman numerals. Okay, so I like to use numbers because they're easier to write and look at. But if I had labeled this as 5, 6, 7, 8, 9, 10, it's still going to be proving whether this side is equal to this side. The important thing is getting the sets out. So here, our universal set is going to be 1, 2, 3, all the way to 8, 5, 6, 7, and 8. Okay, and then our A is going to be everything in the circle A, which is 1, 2, 4, and 5. And then our B is 2, 5, 3, and 6. And then last, our C, which is 4, 5, 6, and 7. Okay, so now we're ready to 5, 6, and 7. Okay, so now we're ready to do the work here. So let me just write it out. So we have A union with B intersected with C. And we want to know, is this equal to A union B intersected with C? And there's a parenthesis over here. Okay, so what we can do here is, again, I normally like to write down what each of my sets are. So for A, I'm going to write it here. So A is 1, 2, 4, 5. So 1, 2, 4, and 5. And then we have union. And then I'm going to have a set here. So B intersected with C. Okay, so B intersected with C. what that means. What does that mean? Basically, what does B and C have in common? Okay, so what does B and C have in common? So do they have, if we look at the circles, or you can look at the sets here, they have 5 in common. And is that our only number that they have in common? So let me write down 5. And they also have 6 in common, right? So we can see that they also have 6 in common. So we're looking at 5 and 6. So now we continue. So now we have 1, 2, 4, 5 union with 5 and 6. So union means put them together. So we have 1, 2, 4, 5, and then 5 and 6. We already have 5, so I just add my 6. And so for the left side, we get 1, 2, 4, 5, and 6. And we want to know if it's the same as the right side. So let's look at the right side now. So we have A union B. So that's what you want to do first. You want to do the parentheses first. So A union B is put everything in A. So everything in A is 1, 2, 4, and 5. That's what we get for A union B. Then we're going to have intersected with C. So let me write C is 4, 5, 6, and 7. Okay, so now we're looking at 1, 2, 4, 5 intersected with 4, 5, 6, 7. So we want to know what numbers does this set and this set have in common. And so let's look. So 1 belongs to only this set. The number 2, does not belong to this set. Okay. The number 4 is here. So 4 is going to be part of that intersection. And then we have the number 5 and the number 5. Okay, so let me close my parentheses here. All right, so now the big question is whether the left side here is the same as the right side. So we can see that they're the same, right? So this is not true for all sets A, B, and C. So this is not going to be true. So I can say in words that it's not true, or you can put a line through your equal sign. Okay. So these are fun, right? So let's go ahead and go to the next slide. So now we're gonna use Venn diagrams to do some application problems. Okay. So we have a music survey. So it says a music teacher has surveyed 495 students, and the results of the survey are listed below. So we have 320 students that like rap music, and then 395 students like rock music, and 295 students like heavy metal music. 280 students like both rap music and rock music. And then 190 students like rap and heavy, and 245 like rock and heavy, and then 160 students like all three. Okay, so one of the things to note here is that we have 495 students. And so if we look at all these numbers that are thrown out over here on the left side, if we were to add all those, it's not going to be 495 students. So obviously there's students who are being repeated in here. So we can use a Venn diagram to help us look at the results a little bit in more detail. So one of the things you want to do is draw a Venn diagram. And we need to determine how many things you want to do is draw a Venn diagram. and we need to determine how many circles are we going to need. So we have to go back to the problem and see what are the categories that are being discussed here. So we have rap music, rock music, and heavy metal. So there's 3 things that they're talking about. So I'm going to have a rap music circle, and then I'm going to have a rock music circle. So I'm going to call this RO, or you can write it out, rock music, rap, and the last one is heavy metal. So heavy metal, I'll call it HM. Okay, so when you're doing these problems, you want to see if you are given any information on intersections. Okay, so basically, and the intersection you want to begin with that would make it a little bit easier is going to be right in the middle. So the one that belongs to, and so if we look at this problem, give me a second really quick. So if we look at this problem, do they tell us which one belongs to all 3? And so let's see. Oops. So Miss Patricia. Oops. Let me see, my screen is acting a little bit weird. So let me see what was on the chat. Oh, okay. So, sorry, I was looking at the wrong chat. All right. So, yes, right. They tell us here that 160 students like to do all 3 things. Okay. So that number, where can we put that number? Right in the intersection. So I don't have enough space here, but I'm going to put a little arrow. And so here we know this is 160 students. Okay. So then what we want to do next is, so we already took care of this one. So now we can look at the intersection between 2 circles. So let's look at rap and rock, for example. So if we read all the sentences, the one that talks about rap and rock is this one here. So they tell us that 280 students like rap and rock. So the rap and the rock is represented by this whole area here. But what's already sitting in there? We already know that we have 160 students that are sitting in there. And those 160 students, they like rap and rock and heavy metal. So they do like rap and rock as well. So to figure out the ones that only like rap and rock, we can take our 280 and we can subtract it by our 160. Okay, so we're going to take 280 and we want to subtract the 160 because we already counted those students when we placed them in this intersection of all 3 circles. And so we get 120. So this little area here would be 120. Okay. So now we go to another intersection. So let's look at rap and heavy metal. So we have rap and heavy metal. They tell us we have 190 students. So if we subtract the 160 again, then we're left with 30. So that's for rap and heavy metal right there. Okay, and then the last one, rock and heavy metal. So rock and heavy metal, they give us 245 students. and we're gonna subtract the 160. So 245 minus the 160 is gonna give us 85. And that's gonna be in this area right here. So this is 85. Okay. So now that we know all the intersections, then it makes it easier to look at each individual circle now. So if we look at rap music, there was 320 students that like rap music. So if I was to pull out my rap music circle, so this is rap, then we can see that inside of this rap circle, we have 120 students here from the intersection of rap and rock. We have 30 students sitting there already. And then right in this intersection of all three, we have 160 students. So we already have all these students that are sitting in here, but altogether we should have 320 students. So what we need to do is we need to add 120 plus 160 plus 30, because those are already sitting in our circle. So we have 0, 11, 310. So we have 0, 11, 310. But if we had 320, and right now we have 310, that means that we're missing 10 people. So those 10 people would go just in the rep area. Okay. So now we can go to the rock circle. So for the rock circle, they say we should have 395 students. In the rock circle, we have, I'm going to write it up here, we have 120. And then we have the 160. And this was 85. So if we add all of this, we get 5, 16, 365. But we should have 395 students. So we're missing 30 students. Now, how did I get 30? We take the 395 and subtract the 365. And then the last one, heavy metal, we have 160 plus 30 plus 85. So if we add those, we're going to have 5, 7, 275 minus 295 gives us 20. Okay, so we have addressed all of these points here. And so that must be our completed graph. But there's one more thing that we need to check. And those are students who are outside of the circles. Students who do not like rap, and they do not like rock, and they do not like heavy metal. So how do we figure out that number? Well, we need to add the 10 plus the 120 plus the 30 plus the 160 plus the 30 plus the 85 and plus the 20. So if we add all of those and subtract from 495, then we're going to end up with 40 students who do not like any of these. Okay. So after we do that, usually the problems are going to have questions. Okay. So, for example, some of the questions that you might be asked is, how many students like only heavy metal? Okay. So now we can use the Venn diagram to help us answer that question. So how many people like only heavy metal? So that would be 20. How many people do not like rap, rock, or heavy metal? So that would be these guys on the outside. So that would be 40. How many people only like one of the types of music? So that would be the 10, the 30, and the 20. So that would be 60 people like only one type of music. How many people like both rap and rock only? Okay. So if that's the question, rap and rock only, then it's 120. So what happens is without the Venn diagram, it would be a little bit difficult to figure out exactly these individual results. So the Venn diagram helps us to really dissect this information and know what these areas are individually. Okay, so that is using a Venn diagram to help us with answering an application problem. The rest of the slides here are just going, oh look, we had the questions here. How many students like exactly 2 of the 3 types of music? So let's figure that one out. How many like exactly 2 of the 3 types of music? So let me put the Venn diagram back so we can see it. So how many students like 2 of the 3 types only? So that would be represented by the number 85 plus 120 plus 30. So that's going to be 235 students that like exactly 2 of the 3 types of music. Okay, and then letter B was like only rock music. I think we answered that one already. Only like rock music would be the 30. And like only one of the 3 types of music, we did that one earlier as well. So only one would be the 10, the 30, and the 20. So 60 people. So the rest of the slides just kind of walk you through what I did and filling in the Venn diagram. If you want to download this Venn diagram, then on the right side, you should see a box with an arrow pointing down. If you click on that, it's going to give you the PowerPoint presentation. I highly recommend that you go to our YouTube channel if you miss the first 2 weeks of the happy hour, because then you can view those 2 videos, and that would also help you to review for exam 1. The first 2 videos talked about subsets and proper subsets and all the other information that came before this. So I recommend you can look at those videos. And we wish you the best for your first exam, whether it's next week or the week after. And I guess next week we'll be beginning the next chapter. So I'll pass it back over to our facilitator.
Thank you so much, Ms. Truca. Okay, so definitely we do want to remind you guys about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. And before we leave, I want to share the lessons that we will have next. So at 1:20, we will have a presentation on Hack the Border, an overview and purpose, and we will be back next week at 11 a.m., where Math 1332 will cover logic statements, truth tables, conditional and biconditional statements, and Math 2412 will cover the Exam 1 review. So at 1 p.m., our session for next week will be a presentation on empowering student success, an overview of the Student Support Services Program at EPCC. Thank you all for coming in today. We hope you all have a lovely weekend. And if you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.